Welcome to a lesson with Dr. Powell. Let's practice taking some general antiderivatives called indefinite integrals. Suppose we have x to the fifth minus 3x to the seventh plus the square root of x dx. Let's try to find a general antiderivative for this. So now taking derivatives as well as antiderivatives, but nicely across subtraction and addition. So we're good there. And then we have power rules for all of these, since this is x to the 1/2. So just starting here, we would have from x to the fifth, we have x to the 6/6. Here, the -3 stays multiplied on, and we have x to the 8/8. Here, this is x to the 1/2. So adding 1 to the exponent, we have x to the 3/2, then divided by 3/2 is the same thing as just multiplying by the reciprocal. So we have 2/3. So when you have fractions, it's like you take this fraction and you multiply by its reciprocal. And then, of course, since it's a general antiderivative, we put a plus c on, and that just means an arbitrary constant that we're adding on. Okay, let's look at one more example here. What if we have the indefinite integral of something like cosine of x plus secant x tangent x dx. What would that be? Well, let's see. We just think about our derivative rules backwards. Cosine and a derivative would be just sine. And you can always check. I mean, check your results to make sure it's really good, because you know how to take a derivative. So after you take an antiderivative, please take a derivative just to verify. So sine x, the derivative is cosine. Secant x tangent x, think of derivative rules backwards. That is the derivative of secant. So we say plus secant x, and then we put a plus c, and we're done. We have successfully taken the general antiderivative of cosine x plus secant x tangent x, which is called the indefinite integral. Thanks for watching.